Sir, we are live now, sir.
Okay, good.
Yes, sir.
So there are, how many people are online at this time? There are, it says 3 waiting. So is that 3-4 people online?
Yes, I think so, sir. But mostly they will join at 4 o'clock, sir.
That's fine.
Yes, sir. But
Good.
already few questions you can see in the chat box, sir. Like 10 minutes back, one student posted. I also.
Yeah, I saw that.
Right.
I can see some of them.
Right, sir.
Hello, everybody. Good evening to
People
you.
are online at this time.
Hello, everyone. Can you hear me? I hope you can hear me. Let's move forward. And now that we have uploaded all the material that we had to upload as far as this course is concerned, I guess you have all the information which we had to give you. And we are now taking on these questions from you, and then we'll try to answer them. And let's move forward to, for those of you who want to take the exam, which is probably scheduled for 21st. Okay. So let me take the first question. This is a question by S.A.M. Zaidi, which says, my question is regarding the one of the assignment statement 1 and statement 2. This is something to do about the mixers, right? So can we take a look at the question? Murli, is it possible to look at the question somewhere?
Just a second, sir. Just a second, sir. I will just try to screen share.
You just do the screen share and we can take a look at it.
Right, sir. Sir, are you able to view the screen, sir?
Yes, I can see the screen also now.
Right, sir. That's the question, sir.
Okay, let me give it a minute. There is an issue here. I have to do some trick. Okay, let me do this and then. So here is the question, Mr. S.A.M. Zaidi. The question says, in the context of reversing drum mixers, consider the following statements. The same opening is used to add the constituents and discharge concrete. The drum rotates in one direction for mixing and the opposite direction for discharging the mix. The answer is, the acceptable answer is that both the answer statements is true, isn't it? So I do not know where the question is from your side. So probably this is a straight question which has been taken from the lectures. And if there is an issue, we'll probably have to resolve it offline. I'll probably post a clarification on the link through the TAs and we'll resolve it from there. Is that all right, Mr. Zaidi? So, because this is something which is straight from the discussion that we had in the lecture that we did, right? Okay, so I think we'll move on to the next question, which the next question is from a person from Kanak Son Take. And what he says is, what is self-compacting concrete? Now, that is a very open-ended question for me to answer. What is self-compacting concrete? Mr. Kanak ji, can you tell me whether you are a student or you are a practicing engineer or what? I mean, because my answer would depend a little bit on what it is. Otherwise, you see, if you have worked with concrete, you will realize that concrete has some amount of pore spaces or voids. The aggregates are not necessarily in the most compacted form or the most compact configuration. So what we have to do is to move the aggregates around after the concrete has been placed. And that is the process, or that is the task which is accomplished by using consolidation or compaction or vibration. Now, self-compacting concrete is that concrete which compacts itself. That is, we don't need to apply external vibration to compact the concrete. And for that, there is a lot of a lot of issues have to be figured out. That is, we have to have the right kind of mixed proportions in order to make sure that the concrete has self-compactability. It has the right kind of flowability, right kind of segregation resistance, and so on. Compacting concrete is essentially a type of concrete which compacts itself. It has the properties of behaving like a fluid. Okay, because at the end of it, that's what in several of my lectures I would have said, that we would like the concrete to behave like a fluid when it comes to the fresh state. That is, when we place the concrete will occupy all the spaces between it will go to the different corners and different positions within the formwork and occupy that position. So it will flow around the reinforcing bars and so on. So if you think of a reinforcing bar, or if you think of a system where the reinforced concrete member is there and there is some reinforcement which has been placed there, if a pure fluid, I mean, you let it be water, let it be anything else, if it is placed, you can imagine that there will be no blockage. The water will flow to all the corners without any trouble. But that is not really true when it comes to concrete, because of the aggregates. The aggregates need to flow through the gaps between the reinforcing parts. They have to kind of move through the cover portion, that is the small gap that we have between the formwork and the reinforcing bars. So that could be a small gap, about 25, 30, 40 mm, depending on what kind of cover you have used. And even that is sometimes on paper, sometimes in the actual placing of the reinforcement, the cover may be less or more. So those are the kind of issues that we have in compaction. And those of you who want to understand compaction a little bit, I don't know, take any jar or something and you put some particles in it, some large particles, some 20 mm, 30 mm kind of particles in the, or whatever you can get hold of at home, fill it up, you will realize that it has to be shaken up. If you shake it up, the particles try to move in a manner that they can get into more compact configuration. Okay, so that compacted configuration is what we want to achieve. And this process of shaking up the jar, that's a normal process that we do at home. That this process of shaking up the jar is like a vibration that is being applied to that system. So as far as reinforced concrete is concerned, or as far as concrete is concerned, that is quite similar to the process, not so much of, let's say, internal vibration, which is almost the same thing, of course, but some kind of form vibration. You take the whole form and shake it up. That's what we do. So that is how vibration works as far as concrete is concerned. And I hope I have answered your question now, Kanak Sontaki, that you have a little better understanding of self-compacting concrete. And if you are able to see some of the videos which are there, I don't think we put any videos as part of our lectures, but there are videos which you will see for the L-box test or the U-box test, and you will realize that, okay, if you have it in the U-box, you fill the concrete on one side and you remove the gate at the bottom, then it will take a shape, it will rise to a height which should be ideally equal, because that is what you expect as far as concrete is concerned if it were a pure fluid. Whereas if it is not a pure fluid and there is resistance to its movement, then we will have problems. That is, it's not self-compacting. Of course, if we vibrate that U-box, then we will probably have the concrete coming to an equal height on both the legs of the U-box. Okay. So I think that is what I want to say. I'll not I'll not spend any more time on this particular question. So let me move to the next one, which says, Mahesh Lalwani, respected sir, when will you provide lecture material? Now, I do not know And you go on to say that in the beginning of the course, you said that you will share some material. Now, I do not know what kind of lecture material you are talking about. I've tried to share as much material as I could. Of course, I made it a point not to share a huge amount of material. I have given you references for a lot of material. So I would expect, Mahesh, for you to make some effort and go to those websites or those download that material which is available at different places and read for yourself. So, I mean, instead of providing you the material directly, okay, this is the material that you can use, or this is the material that is useful, I have deliberately kind of said that, well, I will give you the references, and that will also be a very incomplete, a very sketchy set, because my belief, Mahesh, is that at the end of it, you should be also making a reasonable amount of effort to locate that material. See, in this day and age, for me to give you some material is like saying that, okay, this is what it is. This is the material that please read this. But it will be easier, it will be more permanent in nature as far as retention, your understanding is concerned. If you go through through the trouble or the pain of looking for some material with some guidance, which I have tried to provide, okay? So I think that is what it is. I mean, I think I have not provided too much of reference material, because a lot of that material, instead of being available as links on this particular channel, they are available on the internet. So that those are the references. So please feel free to do your due diligence. Try to find out from from the internet what are the kind of materials that are available to you, and move forward. I think that will be a very interesting educational journey. You'll probably benefit a lot if you do that yourself. Okay. So if there is a specific thing which you have in mind, then you please share with us. You have the different forum on the forum for the course, and we'll try to answer that, and we'll try to give you some guidance on that. But otherwise, I don't see. So I think that's where we'll stop for this question is concerned, and there are not too many questions right now. So I'll just take a small break, and I'll be around. I mean, it's not that I'm going anywhere somewhere. I'm right here. Okay, so now there is some questions have come again in the beginning of the. Devang Panchal says, in what condition the second equation of factor X predominate in the mixed design concrete as given in for target strength? Now, I do not know, Devang, what are you talking about? The second equation of factor X predominate the mixed design of concrete as given in so much for target strength. You will have to be a little more specific. I mean, I don't have access right now to 262. Okay, so let me see. In the process of Mahesh goes back to ask me. So Devang, I'm sorry, I'll not be able to answer this question for you right now. Murliji, are the TS involved in, I mean, also on board as far as this discussion is concerned?
Yes, TS are answering the questions which are posted in discussion forum. We will ask the participant to post it in the discussion forum so that teams will reply to that particular.
We will try to do that. Sure, we will try to look. Please do, Devang, post this in the forum and we try to answer this question about 262, 10262, 2019 for the target strength. Okay. Then Mahesh says, in the process of curing, we are able to cure the outer part of the structural member. What about the inner part? You have a very good point. I mean that there will be a considerable difference in the strength properties of the concrete. You are right, Mahesh, there is a difference. And I have always said, I have tried to explain that in different ways, that as far as concrete is concerned, the whole idea of curing is to make sure that water does not escape from the concrete surface. Now, it is not so much as to provide water for hydration, but to make sure that the water does not escape. So in order to make sure that the water does not escape, you provide water on the outside so that it does not escape. So the question that you are raising is that because of this curing difference, what will happen to the inner concrete and the outer concrete? Now, in one sense, if I were to say that, okay, if we have not allowed water to escape from the surface, then the kind of concrete on the surface and the kind of concrete on the inside is the same. Especially for concretes which are not very large in cross section. That means we are not having any thermal gradients within the concrete. So that means the concrete each element is being subjected to curing or subjected to hydration, let's put it this way. The hydration at each element is going along with or going along at the same temperature. Right? Now, so long as that is assumed and that assumption is valid, then I don't see there is any major reason to believe that there will be a difference in the strength or properties of concrete in the core and the outside. Having said that, in larger concrete members, this assumption is not really valid. And if this assumption is not really valid, then you have problem, because then the core of the concrete is curing or is hydrating at a different temperature, different humidity, different amounts of water being available and so on, compared to what is happening at the surface. And that is likely to cause issues as far as we are concerned. So that is why if you were to actually be very keen to know the exact strength development that has happened within a concrete member, that is something which we do not normally get involved with. So normally we assume that the cubes that we take, and those cubes are only 15 centimeters aside, right? So we cannot, in the cube, the assumption basically is that, well, the concrete is being cured on the surface of the cube as well as the inside at the same conditions of temperature, humidity, water availability, and so on. And therefore, cubes are a good enough measure to measure the concrete strength, and that strength is the same as far as the different parts of the member is concerned. An even bigger problem is that if you are trying to do concrete quality control with respect to cubes and you are curing them underwater, most of the time you are not curing your concrete as such, the entire concrete structure or the structural member, under water. If you're not curing that entire member under water, then there is a problem, because you can say that the cube strength does not necessarily represent the strength of the concrete. That part is very much valid. That argument is very much valid, and that is concrete engineers and academicians, whatever it is, the professionals, we understand that, and we say that, well, that we understand that, but we cannot. But we want to have a certain standard test and standard curing conditions. Now, in that standardization business, we have come up with the water curing or curing underwater at a certain degrees, at a certain temperature, as the standard method for curing. And we say that, okay, we will live with the problem of that strength not representing the actual strength, because the actual concrete may be cured under burlaps, it may be cured with with some kind of sawdust being sprinkled, sprinkling on the, keeping the surface wet and so on. Now, having said that, one of the things which I would like to point out to you is that if you are extremely concerned, and sometimes you had better be, I mean, certain times you can say that, well, that's what I want. In that case, apart from the standard conditions, which is underwater, you try to cure your cubes in exactly the same curing condition as your curing your actual concrete. So you cast the concrete, you keep it in the formwork, remove the formwork, put it in a gunny bag or whatever it is, you wrap gunny bags around it, sprinkle water to it, and then you try to do the cubes, the strength of those cubes. And those cubes, that cube strength, you try to compare with the cube strength that you get or you got with respect to the cubes cured underwater. Now, if once you do that, then you will realize that, okay, what is the kind of difference that you're talking about? Okay, so I think that is something which is a matter of not research, but engineering practice. And most companies do not do it. But there is no reason why in your standard conditions, if you're implementing a project, you say that, well, in addition to concrete cubes being cured under standard conditions, which is underwater, we will also like the contractor or whatever that agency is to cure the concrete cubes exactly under the conditions that we are going to cure the concrete in the actual structure and report the results to us. Of course, in that case, you will have to have a very different set of acceptance criteria. That acceptance criteria which has been given as far as IS 456, let's say, is concerned, will not be immediately and directly applicable. So that has been, in fact, the thrust of a lot of our discussion in this course. Just give me 1 minute. So that has been the discussion that we've been doing throughout this course, that we should try to have a slightly wider view on testing. Okay. So I think let me try to see what's going on with some other questions here. Jagannath Sharma ji is here. What does what know about compressive strength selection, acceptable or failure cube testing and selection? I do not know, Jagannath Sharma ji, what exactly is there a question involved, or you are talking about the acceptance criteria? Those are things which is not very clear from here. And I think if you have a specific question, you will have to put it on the forum and we'll try to see if we can answer it. Okay. Now let me go back to go to another question which I have here from Devang Panchal, which says, for casting M60 concrete only by using superplasticizer possible because maximum cement content is 450 kgs per cubic meter. I think, okay, I got some comments from, let me answer this question first. I'll come back to these things. See, Devang, it's like this. I'm not saying, and it's very difficult for me to say, I mean, I will not get involved with that kind of a prescription thing here, that whether it is possible to do M60 concrete or it's not possible to do M60 concrete with only plasticizers, that is something which has to be determined from or at site. That is, people or engineers at site have to do mixed design. Because this question will involve what kind of cement you are using, whether it's OPC, PPC, what kind of fly ash, how much fly ash, what kind of plasticizer, what kind of coarse aggregates, and so on. So if you are able to do it, fine. I mean, I don't have any issue with that, except that There is one thing which is purely the technical side of it, that okay, you are able to get M60 concrete. Of course, please remember that M60 concrete, as far as we are concerned, would have a target strength of maybe as high as about 70 MPa or something like that, or close to that, depending on what kind of standard deviations you want to use. So with that kind of target strength, if you are able to get it with only plasticizers, reducing your water cement ratio to whatever 0.32, 0.33, whatever you want to get, wherever you want to land up, please feel free to do that. I mean, I don't see any reason why we have I will allow it or not allow it, or I will be happy or unhappy about it, except that then the question will be that if the question is whether silica fume is to be used as, yes, that's exactly what Sarvesh I was coming to. I want to know if silica fume will be necessary. Now, whether a blast furnace slag is necessary, there my answer will be that, well, there are different ways of looking at it. One possibility or one way of looking at that particular side of the question would be that whether it is environmentally friendly. See, from an environmental perspective, we should try to reduce the cement consumption. Okay, because the less cement we use, the less carbon dioxide is being emitted, and so on and so forth. So every kg cement saved is economically viable. It's an economically better option. It's an environmentally better option, and therefore you don't necessarily have to go to the maximum cement content all the time. So in a particular application, somebody will say, well, 400 kgs of cement is allowed. But do you really want to go up to 400? Because the more cement content you push, the more problems you are inviting for yourself in terms of shrinkage and heat of hydration and so on. So I would rather try to minimize the cement content, still getting the right kind of properties in terms of strength and all that. So there, if we are able to use, for whatever it is worth, supplementary cementitious material or something, I'll be happy to do that. Okay. Hello? Galat number. So let me try to move to the next question, which says, Sarvesh Tripathi ji says that I am a regular viewer of your video and develop better knowledge. Well, thank you so much for all this, for the kind words. It's a pleasure to be talking to you, Sarvesh. Mahesh Lalwani says, I was asking for the lecture material in the PDF format. No, the lecture material in the PDF format will not be given. That is a straightforward no. I'm not going to do that. If you are referring to the PDF format of the PPTs or the PowerPoints, then that is not going to be made available. I think that's basically a no way. I'm not going to do that. As far as books are concerned, PK Mehta is not affordable. I don't think there is an affordability problem, Mahesh, because ICI, the Indian Concrete Institute, had come up with an edition of PK Mehta, and I think I have that book somewhere. Let me see if I can locate it right here. Yeah, I can find it. So this is the book. I don't know whether you can find see the book. What I will do is I'll make a scan of this and make it the cover page. I'll make available to you on through the NPTEL office on our portal or something, where our course platform. And this book has been published by the ACC and the ICI, the Indian Concrete Institute, and is reasonably cheaply priced. Let me see how much they are pricing it as. The original edition was much more expensive, but the Indian edition, this is an Indian edition, and I think this should be available and reasonably affordable. Okay, so I think we will try to do something, and you can contact the ICI, the Indian Concrete Institute office, and they should be able to help you with the copies if they have them. Okay. So I think we'll close this chapter on PK Mehta's book, and I think PK Mehta's book is an excellent book as far as concrete is concerned. So let me see if I can do some trick here to show you the anyway, I think I'll not try to use my ability to manipulate an ongoing meeting here, which is online, and I'm not very adept at it. So let me not do that. Murli, just try to remember to point out to me that I should give you a scan of this book, the cover page, so that the students have access to the ICI address so that they can contact ICI.
Sure, sir. I will get the scan copy,
Yeah.
and we will make an announcement.
And ICI has its headquarters in Madras, so I think we'll probably request. We can all. I mean, we can help them do that. So in fact, if they want, maybe we can use the NPTEL office to say that okay, we'll buy a certain number of books, whatever we can do up in that.
Yes, sir. Let's help them out, sir. Yes.
Let's help them out. If somebody wants to approach us, they can please put the request on the portal. We'll try to help you. Okay.
Sure, sir. Sure, sir. Thank you, sir.
Okay. Then there is the comment from Sarvesh Tripathi ji, which says that want to know silica fume uses in concrete. I think Sarvesh, you'll have to read about it on your own. There is this an extensive subject in its own right, and I will encourage you to search for silica fume or supplementary cementitious materials or mineral admixtures in concrete. So silica fume has been used in concrete for a long time. Okay, so there is a lot of information available. In India, you don't use silica fume so much because it's not so easily available. It's probably one of the more expensive materials if you want to use it. So unless we are trying to work with something which will like high strength concrete or something, yes, we will try to use it. So I think that is where I'll have to stop, and you can look at the ACI publications, the American Concrete Institute special publications. And we will probably find some special publications from the ACI website relating or kind of dedicated to these supplementary cementitious materials and silica fume. Okay, so I think that will be that's how you should go about doing it. So then Devang says, your videos are very interesting, informative. Thanks you for excellent presentation. Also, thank you so much. I'm happy to hear that. And of course, it's always it's very encouraging to hear such comments from you and people like you who have been working with this course or watching this course all the time, all through this time. And then there is Devang continues to say, how can we decide which type of chemical admixture to use, SMFC, SNFC, PCE, whatever? Well, it is a matter of compatibility. It's a matter of the effect that okay, what level of water reduction that you want, what is the kind of cement that you're using. So I personally don't have a preference to one admixture versus another. So I mean, it's a matter of compatibility, availability, and so on. So you will have to do that due diligence to find out with yourself, I mean, through your offices and so on, that okay, what are the kind of admixtures available, what is the cost, what do the manufacturers advise you, and my advice will be always check yourself and not rely only on the advice or the literature which the manufacturer supplies to you. That is very important as far as I'm concerned. I'd like to caution you and I'd like to advise you very strongly that please do not rely only on the manufacturer's information, because see, it's not that the manufacturer or the supplier of the chemical admixtures, or for that matter any other material, is telling you a lie. No, the point is that those values, that literature has been generated based on tests carried out in a certain way, under certain conditions. You have to be convinced yourself that yes, this admixture or this material is good for me. Okay. So I think that's where I'll have to close our discussion. The exam date is 21st. Yes, so that is what it is. And those of you who are going to be appearing for the exam, I wish you all the best. And a couple of things which I have promised to give. I hope I am able to deliver on that. I'll try to remember that, and I'll do it through the website, through the TAs. And I would like to take this opportunity to also thank the TAs. I mean, Dr. Prasanna and Mr. Jinish, they have been such a help as far as this course is concerned. And I hope that they have answered your questions to the best of not only their ability, but to your satisfaction. So if you're not satisfied with a particular question, please come back and we'll try to resolve it to the extent possible with the kind of time that we have left with us. Okay. So I think there are two questions which were primarily passed on to which have been left out. One was on 10262 and the other was on the mixer question. So I think both these questions are questions on facts. I mean, we'll have to go back to the facts, and I think with the background that I have given to you in this course, you should be able to answer it for yourself. Okay. Sir, please upload all session videos for download. I don't know what that means. All sessions videos for download. I'm not sure whether is the download of the videos allowed or not allowed for the people who are watching these videos?
Yes, sir, it is allowed, sir. From the NPTEL website, they can download the lectures and watch it offline.
Okay,
so the links are already there, sir.
The links are already there. So that is fine. Now, my only request to you is that we don't want to, we are the whole process of NPTEL, the way it's engineered, the way it is operating, is that it is free for everyone, but please use it discreetly. I mean, you use with discretion, downloading and keeping it for yourself, using it indiscriminately for your good or for the. So please make sure that it's not indiscriminate all the time. Okay, I think that's where we more or less have to close. Now, what is the advantage of using recycled aggregates? Recycled aggregates, the only I'll make a quick comment on that before I close, because I think there's another meeting which I need to go to. Recycled aggregate, environmentally very good. We need to do that, because otherwise there is no way we can use that concrete in that form. And in fact, having said that, we must remember that in order to get recycled aggregate from the concrete, we need to do the processing of the concrete to get to recycled aggregate, to get it to the sizes or the particle size distribution of aggregates. So there is a lot of energy that's required to be put in. But any amount of recycled aggregate that we use saves that amount of aggregate from the natural resources. So it's a conservation of natural resources, which is very, very critical, or the operational part as far as recycled aggregate is concerned. Having said that, recycled aggregates have a problem in terms of durability, not so much of durability, I would say, but in terms of water absorption, they may not be very they may not be the greatest aggregates to use, at least if you want 100% replacement, if you're talking of high strength concrete, or strength even higher than about say 35, 40 MPa kind of concretes. So these are things which are, we have to know that, okay, this is the side effect of this particular material, but then this is what is the advantage of this particular material. And yes, then we have to make a decision that, okay, with knowing all the consequences, we should, or we can still go ahead and use it. So as far as the codes are concerned, 456 allows you to use it, except that is with the permission of the engineer in charge. So the client or the engineer has to approve that. And for that, you have to go and have the right kind of data and say that, well, this is what is the information that we have. This is the data that we generated using our material, our cement, our concrete plant, and therefore please allow us to use it. So it's a case by case kind of a situation as it stands today, provided of course the recycled aggregates meet the basic requirements, and that is already listed down as far as the aggregates are concerned. So I think with this we'll have to close the discussion for today, and if there's something else, then we'll probably have to talk offline through the forum. I wish you all the best and do well. I think that's all I can say. Okay.
Thank you, sir.
Thank you, Murli. Thank you, all of you. All of you who were here took time to come to join us for this live discussion. Hope it was useful to you. Bye-bye.
Bye, sir.